Welcome to Sheba Code. In this video, we will solve a Leetcode problem in under 3 minutes. The problem asks us to write a function that takes in an array of points represented as coordinates on the xy plane and returns the maximum number of points that lie on the same straight line. One approach to solving this problem is to consider each point in the array as a fixed reference point and find the maximum number of other points that lie on a straight line with that reference point. We can determine which points lie on the same line as the reference point by calculating the angle between the reference point and each of the other points. If two points have the same angle relative to the reference point, they lie on the same line. Counting the number of points with the same angle can be done with a hash map. And finding the angle between 2 points can be done by finding the slope between them. It's often helpful to represent points on the xy plane as complex numbers on the complex plane when solving problems. This is because complex numbers provide a powerful tool for simplifying calculations and avoiding the need to remember and apply trigonometric identities and formulas. The relationship between complex numbers and angles is described by Euler's formula, which allows us to perform rotations and other geometric transformations using simple operations like multiplication and division. In this particular problem, finding the angle between 2 points can be achieved by finding the angle of the complex number resulting from the subtraction of 2 complex numbers representing those points. Let's take a look at a C++ implementation. The first thing the function does is initialize the answer to 1. This is because there will always be at least one point on a line, which is the point itself. Next, the function iterates through the array and considers each point as a reference point to the other points. It creates a complex number variable a using the reference point's xy coordinates. The function then iterates through the rest of the points in the array. If the current point is the same as the reference point, it skips it. Otherwise, the function creates a complex number using the current point's xy coordinates and stores it in a variable called b. After calculating the angle between the 2 points using the built-in function, we increment the number of points with that angle in the hash map. Finally, the function updates the answer by taking the maximum of the current count for this angle plus 1 and the current value of the answer. We add 1 here since the reference point is also on the same line. Although the full potential of complex numbers wasn't utilized in this problem, using complex numbers to represent points on the xy plane can be useful when solving problems like this. I hope you found the solution we presented helpful and easy to understand. If you have any questions, don't hesitate to leave a comment below.